Hi everyone, for worksheet 12 is on chapter 7 of textbook 3. Okay, it's applications of trigonometry. So there are basically three different applications: angles of elevation and depression, bearings, and lastly, three-dimensional problems. For 7.1, angles of elevation and depression. Okay, angles of elevation and depression are always taken with respect to the horizontal. Okay, horizontal of the line of sight. So in the diagram, the angle from the horizontal upwards, okay, we call it angle of elevation. Right, and if a person is looking down, the angle that is being formed between the horizontal and his line of sight is angle of depression. Okay, and there's something that is important and also very useful to know. Alright, let's say the distance between a tree and a person. Okay, they are on flat horizontal ground. So the person looking to the top of the tree, right, it forms an angle of elevation. Okay, and if this person walks nearer towards the tree, okay, and he continues looking at the top of the tree, you will realize that the angle of elevation increases. Okay, so the distance, right, as the distance decreases, okay, the angle of elevation will increase. Okay, so the nearer you are to a tall object, as you look upwards, okay, the angle of elevation will be bigger, greater. Okay, one example would be looking at the top of a tree. If you are standing very near to look at the top of the tree, you have to tilt your head much higher than if you are standing far away. Alright, so this is something interesting about the angle of elevation. Okay, so if you refer to the diagram, the man looking at the top of the building, angle TEH, we call it angle of elevation. Okay, and if the man look at the bottom of the building, angle BEH, we call it angle of depression. Okay, example 1 is a simple recap, alright, of the concept using our trigonometry ratio. We have a right angle here. We are supposed to find the height HF. Okay, so HF is opposite of this 12-degree angle, and we have the adjacent side 5 kilometers. So tangent 12 degrees is HF over 5. So HF equals to 5 times tangent 12. Okay, on your calculator, you'll get 1.06278, which rounded off to 3SF 1.06. Okay, so 1.06 is in terms of kilometers, so this is our answer for the height of the hill, 1.06. Alright, in example 2, okay, there are two boats that looking at the top of a lighthouse. Okay, so the height of the lighthouse is 50 meters, and the angle of elevation of both A and B are 48. Alright, this angle 48, degrees, and for both B is 38 degrees. Alright, we're supposed to find the distance between both A and both B. Okay, how can we go about doing that? Alright, all vertical objects, alright, we can assume them to be perpendicular to the ground or to the sea level. Alright, so in this case we have two right angle triangles here. Okay, two right angle triangle. So we can find the length of LB, okay, and then subtract the length of LA. So we'll get the distance that the question wants us to find, which is AB. So for length LB, we make use of the big right angle triangle. Tangent 38 degrees will be opposite, which is 50, over adjacent LB. Okay, so LB equals to 50 over tangent 38 degrees. Okay, tangent 38 degrees. And if we want an expression for LA, okay, tangent 48 degrees will be 50 over LA. So LA will be equals to 50 over tangent 48 degrees. Alright, so we make use of this that we have formed. AB will be LB minus LA. So we use 50 over tangent 38 degrees minus 50 over tangent 48 degrees. We get 18.97687, round off to 3SF, 19.0, okay, 19.0 meters. Okay, next, in this question, BC is a building of height 30 meters. So from the top of the building at point C, angle of depression to a man. So imagine someone is at point C looking down at a man at point A, and angle of depression, alright, is 35 degrees. So note, indicate the angle of depression of the man at A from point C. Okay, so the angle of depression will be here. Okay, remember it is always with respect to the horizontal. Horizontal in this case is CD, because the reference point of looking is at C on top of the building. Okay, so we do a horizontal, which is CD, looking down at point A. So this is angle of depression. Okay, and it is 35 degrees. Alright, so distance, find distance BA. Okay, if you refer to the diagram, there's a right angle triangle here. Now what we can tell here is that the ground, BA is the ground, alright, will be parallel to the horizontal, which is CD. Okay, so we have angle BAC will be equals to 35 degrees because of alternate angles. Okay, and then next we got to find distance BA. Okay, what we can do, use tangent 35 degrees. Right, opposite is the height of the building, 30 meters over BA. So BA will be 30 divided by tangent 35. Alright, we get 42.8444, which is 42.8 meters in 3SF. Okay, and the question asks, there's a man standing at point X, so his angle of elevation to point C is 55 degrees. So calculate the distance between these two men. Okay, we are supposed to find XA. So what we can do, this is quite similar to the previous example. Okay, we can use BA, in order to find XA, we can use BA, subtract by BX. Okay, BXC is another right angle triangle with 55 degree. So what we can do, we can find BX first. So tangent 55 degree will be 30 over BX. So BX will be equals to 30 over tangent 55 degrees. Alright, so we continue to find XA. We use BA minus BX. So we have already gotten BA in part B of this question, 42.8444, subtract by 30 over tangent 55. Okay, we get 21.8382. So rounding off to 3 significant figure, 21.8 meters.